of theta 1 equals
tangent of? I know you guys feel like I'm the crazy one. I'm not. I'm not going to talk about what that implies about you, but you have to start with the equation. You can't start by substituting stuff in. I know you feel like right now, what? It's easy, it's obvious, it's fine, I got it. Okay, but the problem is, in like 2 months, we're gonna have something up there that has 4 different angles. We're gonna have vectors going in all sorts of different directions. You're gonna have to specifically identify which one you're doing. You're gonna have to identify which are the right triangles. I mean, you're gonna have to be able to do all of this, and if you don't start by showing all your work, you're gonna be very confused when we get there. So please, Sean, start with the equation. Tangent of? I'm sorry, I know I stressed people out.
Tan of theta 1.
Okay, we have to
It's the same, equals opposite.
the Chaz, help them out.
It's just theta.
Equals? Keep going, Chaz.
Oh, opposite over adjacent.
Okay. I know, I stress people out, but I apologize. Okay, so here we go. What are we going to do with this? Joe?
Tangent of theta 1
Equals?
y over x.
Okay, do you see how? Step 1, write down the equation. Step 2, substitute in the variables. Step 3, Aileen.
Tangent, wait, is that theta 1?
Theta 1.
Yeah, tangent 33
Yes, equals?
equals y over 4.7.
Okay, so now we have one equation with one unknown. We can solve this. How are we going to solve tangent of 33 equals y over 4.7 for y?
You're going to multiply tangent 33 times 4.7.
Well, actually, technically, I'm going to multiply both sides by 4.7, so it cancels on the right, and we keep it on the left. So what we get here is that 4.7 times the tangent of 33 is equal to y. Therefore, what is y, please? I'm sorry, I missed it. 3.05.
22156.
Okay, that's plenty. Thank you. So 3.052216. What then is the answer for y? Gloria?
Y 3.1 meters.
Meters. Okay, great. We have our answer for y. What are we going to do next? We're trying to figure out the hypotenuse and theta 2. Color.
If we want to, do we want to solve the hypotenuse next?
We also want to start for the hypotenuse and theta 2. I don't care what we do next, right?
If you want to solve the hypotenuse, you use the Pythagorean theorem.
We could use the Pythagorean theorems. Coloring of what is the Pythagorean theorem?
A squared plus b squared equals c squared.
Wouldn't it be nice if it were consistent? Okay, we have A, B, and C. A squared plus b squared equals c squared. The Pythagorean theorem. Please be aware, in order to use SOH CAH TOA and the Pythagorean theorem, what type of triangle do you need to have? Anthony. A right triangle. In the absence of a right triangle, you cannot use this stuff. So we could use the Pythagorean theorem. How are we going to use this theorem, please, Jimmy?
You can first have x squared, start with a squared plus b squared equals c squared. Then we're going to substitute in, so it's going to be x squared plus y squared equals h squared. And then it's going to be 4.7 squared plus 3.1 squared equals h squared.
Therefore, solving for the hypotenuse, we get the hypotenuse equals the square root of 4.7 squared plus 3.1 squared. One hand. Only one person's raising their hand. I need more. I got 3 now. Steven. There's no Steven. I don't know why I looked at that. Joe, that doesn't make any sense.
5.6 meters.
Not what I'm looking for. Thank you, though. Lauren.
5.6.
Sorry, not looking for an answer. I'm looking for a question at this point. I'm sorry. And right now, we're not going to get a correct answer from what's written on the board. Jens.
You can't do the square root of everything.
No, actually, where this algebraically it's correct. It's that the numbers are not correct. Here.
Wouldn't they just cancel out because the square root?
No, this algebraically everything is correct. You're going to take the square root of everything under the parentheses. Chloe.
Do you have to use the original, like, non-rounded?
You can't use the rounded number in a problem. That's why we write the unrounded number here first, because that's the number we need to use when we're going to use this number in a problem. You have to be really careful. When you are giving an answer, you need to round the correct number of sig figs, but if you're going to use that answer, you need to use the unrounded number. 3.052216 is what we're going to square. 3.052216 quantity squared. The hypotenuse is equal to. Now I will accept an answer. Done.
5.604107.
That's plenty, thank you. So with sig figs, we get, yes, sir.
Would it be okay if you had less digits over there, but then you used the number still in your calculator and brought it out to more digits?
Okay, here's the thing. When I do it, I will simply use the answer button or store it as a macro or whatever. But you need to be able to illustrate that you're using more sig figs. So when you do this, you should always write down a number that has at least, I'll say, 3 sig figs more than what are necessary, so that you're showing that that you're using the non-rounded value.
Right, but then over there, can you use something that's like 5 sig figs more in your calculator?
I would just use maybe, yeah, well, in your calculator, yeah, I would just use whatever it is
Yeah.
in your calculator, the stored value or whatever.
Okay.
Yes, absolutely. Okay, so 5.604107, so we get, with sig figs, 5.6 meters. We're close. We have figured out the hypotenuse. By the way, there was another strategy on the board to figure out the hypotenuse. Who can tell me what it was? What it is? It's still there. Donald.
You could sub in the y value now with sine 33, so you could say sine 33 equals...
We'll just stop there. I agree, we don't need to walk all the way
Yeah.
through it. But if you notice, we got stuck. Lauren picked one where we had 2 variables that we didn't know. But we got to the point where we figured out what the y variable was, so we could have come back here and used that. This is also correct, it's going to be the same thing. It's just wanted to point it out. So we're close. We have the hypotenuse, we have the y value. We need theta 2. How? We're going to figure out theta 2. Cody.
You start out with, to solve for theta 2, theta 1.
I do want to review, you could use this on a quiz or final exam, but it doesn't review something I would definitely want to review. So what's another strategy? Eileen.
Sine A over A equals sine B over
I don't use the law of sines. I do understand you could use the law of sines, but it's a lot, in general, fewer of my students know that than this. So you're more than welcome to use the law of sines, but I'm not going to use that right here. Sorry. Sean.
Sine theta equals opposite over hypotenuse.
Yes. He started with an equation. Did you hear that? Started with an equation. What is our next step? Sean, keep going.
Sine of theta 1 equals x over h.
Okay, here's the problem. I agree, that is correct. But why doesn't this help us with where we are? Jimmy?
We know all those values.
We know all those values. Remember what we're trying to find. What are we trying to find, Jimmy?
Theta 2.
Theta 2, okay? So the issue here is that we already know all that. So sine of theta 2 then is equal to, Emily?
X over
Prescott, keep going from here, please.
You'd have sine theta 2 equals 5.604.07.
Great. Now what? Our goal is to solve for theta 2. McCutcheon, what's our next move?
Divide 4 by 7 by 5.
We don't need to get a number. I agree, we have that, we can get a number, but there's no reason to do anything with that on the board.
Take the inverse sign of that number.
Okay, we're going to take the inverse sine of the whole thing. We'll do it in 2 steps. The inverse sine of the sine of theta 2, we're going to take the inverse sine of both sides, is equal to the inverse sine of 4.7 divided by 5.604107. The inverse sine of the sine of an angle is just the original angle. So theta 2 is equal to the inverse sine of 4.7 divided by 5.604107. McCutcheon, I generally won't substitute that in. There's no point in doing that. Yes?
You have to show that first step.
I would say this step right here I do today, but I won't do again. I found that it's helpful when I show it today, but really it's kind of half the step. Theta 2 is equal to, please. Holy cow, 57? Wasn't exact though, what was it?
0.0005.
Was that 4 zeros? 5 zeros? Good enough. So with sig figs, lo and behold, it works out to 57 degrees. One would know that by using theta 1, theta 2 plus 90 is equal to 180 degrees. You can see it's going to work out to be 57. But I wanted to review this piece right here. It's a very important piece. Cosine. Okay, that's fine.
We're looking at this on 180.
Absolutely, and I'm going to review. On a quiz or final exam, I would certainly suggest that you do it that way. It's quicker, it's easier, but there are going to be instances where you can't. You have to do it something like this.